Hey guys, I hope you're having a wonderful day. Today we're going to talk about linear regression. So before we get started, I do want you guys to have this set up with me. I want you to have your notes, and then on the side I want you to have the checklist for this week. Okay? Alright, so let's get started. First, our essential question is, what are the different types of regression? And let's go ahead and talk about what regression is. So regression is going to be the line that best represents the data on a scatter plot. Okay, so a scatter plot is basically like a XY graph with just different points everywhere. Okay, that's what a scatter plot is. Linear regression, you guys know it as the line of best fit. That's also a different name for it. Okay, so we are going to talk about two types of regressions. We're going to talk about linear regression, which is the first one right here. You're going to either have a positive regression, a negative, or a constant regression. Okay? And then the other one is going to be a quadratic regression. And this is where our data looks like a parabola, either opening up or opening down. Okay, so for the steps on linear regression, they're actually pretty easy because we just use the calculator to find it. Okay, so the very first step is to plot the points on the Desmos statistic linear regression calculator. Okay, this calculator you can find it here in our checklist where it says statistics linear regression calculator. Just go ahead and click on that and this should come up. Okay, it already has an example for you, but we're not going to use that example. We're going to delete them and put in some new data points. Okay, our second step is going to be look under parameters and find the values, or the value of m and x. So here in parameters, right here it says parameters. Here for this example, m is equal to 1.329 and b is equal to negative 0.296. We will use both of these, m and x, to do our last step, which is plug in m and b into your y equals mx plus b form. Okay, and once you have that, you have your equation for your linear regression. Okay. So let's go ahead and do our first example. Okay. And it says plot the given pairs and then determine the equation of the line of best fit. So remember, the line of best fit is going to be the line of regression, the linear regression. Okay, so here I have these plots, and so right here in the statistics linear regression calculator, I'm going to plug in the x's and the y's. Okay, so first I need to delete everything that's in there. And so for my x values, I have 1, 2, 3, 2, 2, 1, 3, 2, 3, oh, not 33, 3 and 1. Okay, and for my y values, I have 3, 2, 17, 18, 7, 11, 20, 10, 6, 12, and 0. Okay, so it might take a while for you to plug those in, but here we have all the plots, and that's my first step, right? Plug in all the plots into the calculator. Once we have everything, we're going to scroll down, and we have m and b right here. Okay, right here. So here my m, I'm going to write down my m, is equal to 4.14894, and my b is equal to negative 0.170213. Okay, remember these two numbers, I got them from right here under parameters. I have my m, which is my slope, and my b, which is my my y-intercept. Okay, I want to run it to do 2 decimal places, so I'm going to look at these two values. This 8 is greater than 5, so that means that this 4 is going to go up a value. So my new m is going to be 4.15. Okay, my b, my two values I'm looking at are 7 and 0. And 0 is not greater than 5, so this 7 stays where it is. Okay, so my b is equal to negative 0.17. Okay, so my last step is to put those two together into a y equals mx plus b form. So my y equals mx, my slope is 4.15x plus my y-intercept, which is negative. So you can put a plus negative 0.17, or we can do a minus 0.17. And that is my answer. This is the line of best fit for this graph. Okay. Now let's go ahead and do another one. Let's do this one. So here I have my list of values, so I'm going to go ahead and delete these. And then, okay. Oh, okay, let's see how fast I can do this. So I got 4, 6, 2, 1, 8, 5, 6, 3, 8, 0, 1. Okay, and then for my y values, I have 2, 0, 4, 2, 1, 1, 3, 3, 0, 4, 3. Okay, so here let's zoom in and look at these. Okay, so hopefully I did not miss any. I don't think I did. But my m and my b are under parameters right here. And it says my m, let me write down, my m is equal to negative 0.3875, and my b is equal to 3.64091. Okay. Hopefully everyone can see where I'm talking about. So right here where I have this highlighted, it says statistics and then residuals and then parameters. Right here under parameters, that's where I'm getting my m and my b. Okay. All right, let's go ahead and round our decimals to 2 places. So I'm looking at, for my m, I'm looking at 8 and 7. 7 is greater than 5, so that means that this 8 is going to go up 1 to a 9. So we got m is equal to negative 0.39. Okay. On my b's, I'm looking for 4 and 0. Okay. Here, 0 is not greater than 5, so that means that the 4 stays where it's at. It stays. So my b, my y-intercept is 3.64. Okay. Put them together into your y equals mx plus b form. We get y equals, our slope is negative 0.39x plus 3.64. And that is my answer. Okay, these are pretty easy. Okay, so let's go ahead and do a word problem. Okay, so for this question, we have a zookeeper recorded the feeding schedule for a baby rhinoceros for 20 weeks. The table and scatter plot show the percentage of the baby rhinoceros's body mass that was used to determine the amount of food given at each feeding as a linear function of its age in weeks. Okay, what is the best prediction of the percentage of the baby rhinoceros's body mass that should be used to determine the amount of food given at each feeding when it is 25 weeks old? Okay, so if you guys notice right here, I already had, we can predict that it's going to go down, right? Because in a scatter plot, we can draw like a line of best fit, and we know it's going to go down. Okay, so first, I know we have it all listed out here, but I'm going to use our statistics linear regression calculator to find the line of best fit for this one. Okay, the exact equation. Okay, so for my x values, which is the age, I'm going to put the first row, which is 1, 2, 4, 7, 9, 12, 14, 15, 17, and 20. And then for my y values, I have 20, 19.5, 17, 15, 14, 13.5, 12.4, 11.6, and 11 and 9. Okay, so here is my linear regression model. And then let's go ahead and find our m and our b. So our m, remember we're looking at this right here, and we're looking under parameters. My m is negative 0.544817, and my b, my y-intercept, is 19.8027. Okay, so for our rounding, remember it's 2 decimal places. I'm going to look at 4 and 4. This 4 is not greater than 5, so I'm actually just going to leave it as negative 0.54. Okay, so I'm just going to go ahead and erase that part. For my b, I have 19.80. Oh, no. 02. The 2 is not greater than 5, so again, I can't change it. I can't change the 0 to a 1 because 2 is not greater than 5. Okay, so these are my m and my b. And we have y equals mx plus b, and we're going to go ahead and plug in our m and our b. Okay. But our question is, we want to determine the amount of food given at each feeding when it's 25 weeks old. And again, this is going to be a best prediction, so it's not going to be the exact answer of the question of the answers that they give us. So 25 weeks is actually going to be our x values because age is in weeks. So right here for my x value, I'm going to put 25. Okay. So in my I'm going to go to my checklist, and then I'm going to go here where it says scientific calculator, and I'm going to put in my equation. So I get negative 0.54, and then parentheses 25 for 25 weeks, plus 19.8, and then I get a 6.3. So 6.3, or let me write that down. Y equals 6.3. So at 25 weeks, the percentage of body mass is going to be 6.3, about 6.3%. Is about 6.3%. Okay. So our answer choice here, we don't have 6.3, but the closest one that we have is 6%. So our answer is, that's a really big marker, is 6%. Okay. Remember, because it's a prediction, and line of best fit is going to be just a prediction of what that line could be based on the scatter plots that we have. Okay. Right. So remember, on your checklist, you have one linear regression question. It's a Google form. Remember, use the statistics linear regression calculator, and then find your m, your b, and then you're going to put it together as y equals mx plus b right here. Okay. So if you have any questions, I'm always here to help you. I hope you have a wonderful day and get this done early so that way you guys can work on your finals.